So here we are talking to Betu and Sarah. These are two astrobiologists, which just has to be one of the coolest career paths ever. And we want to find out a little bit from them about what they do.
I'm working for the Center for Ribosomal Origins and Evolution at Georgia Tech. And I'm an astrobiologist. My work is sponsored by NASA Astrobiology Institute. And my research is really structured around evolution, and I want to understand if evolution is repeatable. And for that, I have a system in the lab where I create a molecular time machine, as we call. So I go back in time and resurrect these genes that are like millions and billions of years old. And then I bring them back to life. And I put them in the bacteria by replacing the modern component of the bacteria. And then I push the button of evolution. And then I replay it to watch if the evolutionary process for these genes will repeat itself. So it's like waking up these sleeping beauties that has been sleeping for millions of years.
I also work for NASA Astrobiology Institute, and I am really interested in the origin of life. So I'm critically interested in what differentiates life from non-life, and I'm trying to figure out how that transition occurs. And one of the key features of that is trying to understand not only how life started on Earth, but how it might start in other planetary environments, so how common life might be in the universe. And my background is actually in physics, so I try to apply sort of fundamentals from physical phenomena and try to apply these sort of mathematical principles to understanding how life might get started and if there are sort of universal principles underlying that.
I mean, actually, I like to call it bacterial Jurassic Park. It really is like using an algorithm and the tree of life, thanks to Charles Darwin, and like going back in time. It's really all computational first, but then thanks to synthetic biology too, that we can actually take these genes and turn them into some meaningful proteins that we can actually see them in the tube in the lab. So it starts with a computer and then translates back into the actual chemicals in the lab, and then we can do whatever we want with them by baking them up and say, okay, evolve.
Wow, fantastic.
Well, I have my PhD is in biochemistry, so I have a chemistry background, but I wanted to ask the big questions that I have one lifetime to spend, and I want to go for it. I want to do something that's actually meaningful, and I want to ask the question, what is life? What's the meaning of life? Okay, one way to answer that, I think, is science, and I think astrobiology is actually translating into something that actually can give me an answer for that. I can make my life so meaningful for looking at the question that has been asked for like centuries and centuries by a human being. So I'm not sure if I will find the answer for it, but at least I will give it a go. We'll see.
Yeah, for me, I was always interested in theoretical physics, and like the pillars of theoretical physics were always kind of this idea of understanding what the universe was at a more fundamental level. But it really kind of is this really reductionist approach to nature, and so you're really trying to figure out at smaller and smaller bits what the world is made out of, but it kind of neglects all the beauty and complexity we see in our daily lives, and life is such a special phenomena that we really need to understand in the context of physics. And so astrobiology is kind of an interesting science because it really takes a cosmic perspective on life. And so for me, it was just so inspiring to try to understand, our place in the universe. And as somebody that really wants to understand fundamental science, it was just like, I was just like, oh, it's just so awesome, So no, seriously, it was like an aha moment. So I had spent like years and years and years chasing fundamental physics, and I was like, there's something very, very fundamental in our understanding that we have a huge gap here. And so what can we do to try to understand it? No, seriously, it's just awesome stuff. So for me, coming from a background sort of in theoretical physics, is a very male-dominated field, and it's just very exciting to be in a field that's just so new, and there's so many just excited young people, and I think it's just that generation. They're just like, this is an entirely new discipline. We don't really care what anybody did before. We're just going to go out there and try to discover.
Well, women are smart. We know where you can get the good science. That would be my explanation. And it's also, I think, what you said is really true, permanent versus interested. And I think astrobiology, you need to have a sense of thinking where you don't have any boundaries. So, I mean, you cannot just look for life in the universe. You want to understand the whole universe, and then, come to a level where you separate men versus, women. That would be such a small-minded thing, and that does not exist in science, hopefully, but it does. But I think astrobiology requires really big thinking. I don't think we have room to, come down to, oh, you're a woman, man, whatever. I think we're so over that in astrobiology.
Right, so we're with Karen Venti, and we would like to hear a little bit about what she does.
Sure. Well, I'm in the cancer field. I got my PhD in biochemistry, but as part of my thesis project, I worked on characterizing a tumor suppressor protein. So essentially, it was my job to understand what this protein does and how it suppresses tumor growth. I was always interested in writing, and for the majority of my graduate studies, I was trying to find a way to marry my writing interests with my scientific interests, and obviously my research project was based on cancer research, so I really wanted to find a way that I could marry the two in my professional career, and so this was the perfect venue for me to really, be able to learn about cancer therapies, communicate about cancer therapies, and just basically look to where the future is going with cancer research.
Hi, I'm here with Canopy Meg Lauman. Where are you?
I am the director of the New Nature Research Center, which is a wing of the North Carolina Museum of Natural Sciences, and I'm also a professor at North Carolina State, a joint position.
That's brilliant. And what do you do? What is your research about?
My research is in tropical rainforest canopies. I had the dubious honor of being one of the first people in the world to climb trees searching for biodiversity, and way back when I first started climbing, we found out that over half of the terrestrial biodiversity lives in the tops of trees.
Things have probably changed a little bit since you were the only PhD student in the program. Do you think we have made some strides?
I think we have definitely made strides. I'm overly optimistic perhaps, but number one, I'm always excited to mentor women. I think one of the missing links for me was the fact I never had a woman professor. And number two, I think society is now cataloging and creating statistics out of these different kinds of gender issues. However, I would add that we've done some surveys here in the States. I've been the vice president of the national association of my profession called the Ecological Society of America, and our findings pointed out that even though women were getting 50% of the PhDs, less than 10% of women are in the leadership positions, and there's a lot of attrition during childbirth years. So somehow we still have to figure out metrics that allow women to come back in the field or not to fall behind in the eyes of their male colleagues. It's just a tricky business, what I would call perhaps the invisible glass ceiling, yes, rather than the visible one of the past. The issue of women in science is very complex. My college roommate is a doctor, for example, and it was very easy for her to work 3 days a week, have very high rates of calling. Her fees did not go down, her income did a little bit, but there were so many ways that her field catered to her needs and choices, and I think in science, women seem to be either in or out. There's a lot less prestige right now associated with part-time positions, or women tend to become adjunct or lab assistants or positions that don't have any place on the ladder of achievement and moving up. So somehow we haven't quite grasped it. I think there's a lot of intimidation in the field to publish in a prestigious journal, and maybe less reward for some other activities that can be done on a part-time, and this is where I think we might see change in the next generation. What about scientists going to schools? What about scientists mentoring minority students? What about scientists getting involved with policymakers? All of those activities can be done on a more part-time basis, with a different level of energy, and if we could bring those into the tenure process, into the reward process of how scientists have the metrics of achievement, then maybe we could allow women to have a life.